So we focus to the example 3, mechanism, page 94. The similar target question. Write the mechanism for the reaction dehydration of alcohol, and we try find out the side product form is water. So it should be your mechanism. The type of reaction must be elimination reaction. So remember this step, we have a 4 steps, so we consider for the first step. So in our first step, you must be starting from our organic compound, which is alcohol, because the first step is protonation of alcohol. We gain the proton from the reagent towards to the alcohol, so it must be reacted with our reagent H2SO4, and we rearrange the atom in H2SO4 as here. So the step occur must be a lone pair from the oxygen will form covalently bond with the hydrogen atom in sulfuric acid, and at the same time the bonding between H and O will occur, cleavage. So electron both here given directly toward to the oxygen, and the finalized product, so this occur is a fast step reaction because we just added the proton from the sulfuric acid, and we can form the final product. Proton is added to the hydroxyl area. So this area, oxygen have one lone pair covalently bond with hydrogen, and the new product, the new covalently bond with the hydrogen atom, and our side product form here is OSO3H minus. Why minus? This oxygen, the formal charge is -1. So after the product form, we need to trace first. This oxygen become charge positive because less of the electron, and target kita adalah penghasilan second step carbocation. So we copy it again, the organic compound. So the positive charge is oxygen. So we know that this oxygen require electrons. So what happened? The cleavage occur between carbon and oxygen. So the two electron will give directly toward to the oxygen plus here, and the product can be formed. The carbocation occur. So CH3, 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 CH. This is a CH3, and this side carbon become charge positive, can call carbocation, and this process can detect the elimination of the water molecule. So at this stage, we need to trace either stability of carbocation need to rearrange again. So this C plus attach one to alkyl group mean this is classified as a secondary carbocation. So we need to proceed to the third step. We need to trace either tertiary carbocation occur or not. So means that the third carbon here have a CH3 group. So means it can rearrange to find out tertiary carbon carbocation. In this step, rearrangement, we need to change a secondary carbocation to form tertiary carbocation, because tertiary is the most stable carbocation. So what happened at the carbon number 3 here, we just have a methyl group. So what happened? The bonding pair including the methyl group must be shift directly toward to the secondary carbon. So the product can be formed at this stage. So CH3, CH3, C, this is hydrogen, and this is CH3. But differences for the product and the reactant, the CH3 must be attached to the second carbon. Why? The carbon number 3 will become carbocation, and we trace C plus attach 1, 2, 3 alkyl group. So this classified as a tertiary carbocation. So this stage we shift what? Methyl group. So if we shift methyl group, we need to label 1, 2 dash methyl shift. So for last step is the formation of the alkene. We need to remove H atom because it's need to form the water. So what happened? This carbocation must be reacted with the species nucleophile OSO3H minus. So this we have a lone pair at the oxygen. So the process involved, the lone pair of oxygen will take out hydrogen. This hydrogen, the criteria, attach carbon neighboring to the carbon-carbon cation. So the two electrons in sharing together will stabilize their own carbon and carbon cation to form the carbon-carbon double bond. So the product form CH3 C CH3 double C CH3 CH3 plus HOSO3H mean the sulfuric acid form again, and we can make the conclusion the product form the most stable alkene, carbon-carbon double bond attach 1 2 3 4 alkyl group. So this is clarified as a major product.